Hi everyone. Today we are gonna present fine-grained wildlife species recognition, and our team name is IdentiFine. So I am Behrouz, and my teammate is Marco. So we're gonna go ahead and tell the motivation and significance of this project, which is that like manual species and uh, their labeling is very slow and error prone. And as you know, there are millions of camera traps out there in the jungles, and which requires automation and which has not been done yet. And the rare species in the jungle, and to preserve them, you need to first detect and label those species and to study their pattern, like at what time they come at some specific spots or not. So the traditional models, they don't work well on these rare species. And in order to, solve this gap, few short and one shot learnings enable this type of recognition with a limited type of samples. So what does the two images tells us is that these two animals in the images, they look same, but they are not. So one of them is a rare species which matches with the other animal, which is very common. So in order to identify this, this is the major research gap and motivation behind our project. So the dataset that we used was iWildCam dataset, 2022 version from Kaggle, and it has multiple species. So top species and rare species are also in there. So the below chart, it tells us the top 20 species of the iWildCam dataset. So in that, the names are there and the count are also there, in which it clearly states like one of the top species in the dataset. So now we come to the problem formulation and background. So the problem in main problem statement was that there was extreme long-tailed class imbalance in the dataset, and there was multiple domain shift of species across multiple locations, and poor lighting was there in the images in the dataset, noise was there, so we had to perform multiple data pre-processing. And the traditional CNNs which worked on these specific problems, they fail on rare species. And there's another problem, which is massive data set. So the chart on the left tells us the top 15 location where most of the animals appear, and on the x-axis, these are the code names of the location which is saved in the dataset. And on the right, you will see a bar chart. On the red bar tells us the species that only appear once, which are 57 species, and the orange chart or yellow chart tells us the species that we have images under 10, which are 138 species. And these are the species that we mostly focus on in our problem and in our project. So the related works is like few short segmentation. It improves the rare species dataset and detection. So we research about that and we are using it in our project. And real world few short learning, it struggle with the environmental noise. So we did some pre-processing, a further step ahead to tackle that problem. Then we did two-phase training to handle tail class recall in few shot and one shot by combining it and making a new approach which we will explain further in detail. And the baseline models for these projects are ResNet 50 and Inception V3. And the accuracy and F1 score of these two models are there, and it's not that good. So that's why we found a gap and we worked on this. So the experimental setup that we set for this is that previously the iWildCam original data set is uh, in total 340 gigabytes, and it's very large data set, and we came across multiple space constraints in the OneDrive as well and in the local hardware as well. So we faced that problem a lot. We tried to use HPC as well, but we were still coming to the same point, memory constraint. So we cut down the dataset into 40%, and it was random splitting of the dataset due to obviously resource limitations, but it was still 130 gigabytes, which is a lot. And it took us a lot of time to figure out this problem. Then we are using Python language in this, and accuracy, loss, F1 recall. And resources that we used are Google Colab Pro, and the GPU that is used for training was L4 GPU. And on the left you can see that dataset is drive is mounting and dataset is loading. And on the left you can see the specs of the resources of the GPU and the RAM and the disk that we used. So the proposed methodology architecture, so we used hybrid approach with the combination of protonet network and CMA's network. And what does protonet network is? So protonet network is basically few shot learning technique, and it's widely used and one of the most commonly used in the images with which are under 10 or which are above 1. And the other network or CMA's verifier network that we used is used for one shot technique, so it works on even the one image. So these both are deep learning models, and we trained that. So the first technique we did pre-processing, then we did data refinement, and then the feature extraction was done through protonet network. Then feature processing of those feature extractions were done using CMA's network. And then the hybrid approach came in the hybrid approach, what we did was the combination of both. For example, if a species has more than one image, so those images will go to CMA's network, protonet network, and the image has only one species has only one image, then that will go to a CMA's network prediction. Then the predictions were done. So now we come to the model training part. So Protonet trained for few shot learning. As you can see, we ran 10 epochs, and we achieved the accuracy of 95.95% and loss of 0.11%. And for the CMS training, what we did, we ran 15 epochs and we achieved the accuracy of 94.75% and the loss was 13%. And this the evaluation was done on as well on the iWorldCam 2022 validation data set, and they all work together in a hybrid approach. So from here, my teammate Marco will continue.
Thank you. So now moving on to our results, even though we worked, like we said, with the reduced version of the data set, due to storage limitations, our hybrid approach still performed really well. Like we can see here, Protonet alone showed a solid few shot performance, and CMEs was really good at one shot predictions. Um, and what our goal was coming into this project is to make a hybrid model that is better than each individual model on its own, and that is what we achieved. Now, moving on to our top performing classes. This is our top 15 performing classes by F1 accuracy scores. And a lot of these classes are the same classes we saw in the most common bar chart, and that is due to the excess of images that we had in the data set with different lightnings, different times of day, which allowed the model to perform really well. And the specifically the classes shown are the classes that both Protonet and CMEs did really good on. Now for our discussion slide, um, rare species still remain our hardest challenge. They have the weaker recall, and the model often defaults to the more common species rather than identifying it as a rare species. This is mostly to lightning, motion blur, and occlusion still having a big part on the embedding quality, and because rare species have less pictures, it causes the model to predict them less often. Um, Overall, our hybrid system did great, but some of the data set imbalances and the real world conditions are still challenging. In conclusion, um, we successfully fine tuned a hybrid model with Protonet for few shot and CMEs for one shot recognition. Even with the reduced data, we got very promising results. So for our future work, we plan on training this model on the full data set so our results are even better. And we plan on implementing zero shot learning so we can use the model even on the animals that do not appear in our training data set. And for team contributions, they're listed on the screen. We made sure to distribute the work evenly, and that both of us gain knowledge and experience during every single part of this project. The references are also listed on the screen, all five of them, including the IVAL CAM dataset. And thank you for listening to our presentation.
Thank you for your attention, everyone. That's all from our side.